Dear students, welcome back to the next session of mathematics. You have so far learnt about algebraic and geometrical representation of a pair of linear equations in two variables. We have seen that when we represent a pair of linear equations or a system of equations graphically, the lines either intersect or coincide or are parallel to each other as shown below. These are the three graphs that were shown to you in the previous session. Here, in the first graph, the two lines are intersecting. In the second one, the lines are coincident. And in the third ones, the lines are parallel. So, if we want to see whether the two equations represent intersecting lines or coinciding lines or parallel lines, we need to draw the graph of the two equations and then decide what kind of representation they will have. But my dear children, drawing graphs is not the only method of determining the graphical representation of a given system of linear equations. We can also do it in another way. Just have a look. The first graph that was given to you had the lines representing the two equations given by x minus 2y equal to 0 and 3x plus 4y equal to 20. Let us try to put them in the general form of a1x plus b1y plus c1 equal to 0. Here we will get x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0. So a1 and a2 are the coefficients of x in the two equations respectively. b1 and b2 are the coefficients of y in the two equations respectively, and c1 and c2 are the constant terms. So just see what is a1 and a2 in the two equations. It is 1 and 3. Find out a1 upon a2. We get 1 upon 3. Similarly, b1 and b2 in the above equations will be minus 2 and 4. So b1 upon b2 comes out to be minus 2 upon 4, that is minus 1 upon 2. c1 and c2 in the two equations are 0 and 20, minus 20. So we get b1 upon b2 and a1 upon a2, they are not equal. Therefore, whenever we have the lines that are intersecting, they will always be representing the equations having coefficients such that the ratio of a1 and a2 and b1 and b2 are not equal. That is, a1 upon a2 is not equal to b1 upon b2. See the second case. The second case had coinciding lines. If you see the equations that were being represented by this, they were 2x plus 3y equal to 9 and 4x plus 6y equal to 18. Putting them in the general form of a1x plus b1y plus c1 equal to 0, we get 2x plus 3y minus 9 equal to 0 and 4x plus 6y minus 18 equal to 0. So a1 here is 2, b1 is 3, c1 is minus 9 and a2 is 4, b2 is 6 and c2 is minus 18. Check what is a1 upon a2. It is 2 upon 4, that is 1 upon 2. What about b1 and b2? It is 3 upon 6, again 1 upon 2. c1 upon c2 is minus 9 by minus 18, again 1 upon 2. So here a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. That is, whenever we have two equations for which a1 upon a2 equal to b1 upon b2 equal to c1 upon c2, we will always get two coinciding lines. Thus, the condition for the lines to coincide is a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. In the previous one we had a1 upon a2 not equal to b1 upon b2 where the lines were intersecting. But here a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2 where the lines are coinciding. Let us come to the third case. The third case was when the lines were parallel to each other. So the equations that represented the lines were x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. These two equations are already in the general form. So a1 is 1, b1 is 2 and c1 is minus 4. a2 is 2, b2 is 4 and c2 is minus 12. What is a1 upon a2? It is 1 upon 2. b1 upon b2? 2 upon 4, that is again 1 upon 2. But c1 upon c2 is minus 4 by minus 12, which is 1 upon 3. So clearly we have a1 upon a2 equal to b1 upon b2, but not equal to c1 upon c2. And we are having the representation as parallel lines. So clearly we have seen the condition that if for two equations a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2, then its graphical representation would be parallel lines. Recall that every point which lies in the straight line is said to be its solution. For example, consider the following equation again. X minus 2y equal to 0. The solution set for the above equation is given by, can you recall in class 9th how you made the table? X and y, give a value to y and find out the corresponding value of x. So you put y equal to 1, you get x equal to 2. You put y equal to 2, you get x equal to 4. You give the value of y as 3 and you get x equal to 6. Which means that the points 2, 1, 4, 2, 6, 3 lie on the line represented by the given equation. Let us see another term, consistency and inconsistency of the system of equations in two variables. Consistent means what? It means something that's stable. Stable means that the equations are such that their solutions can be found. Means that the solution for these equations exists. So if we see the first graph where the lines were intersecting, if the lines intersect, they meet each other at exactly one point. That is, they share a common solution. In the graph, we see that the lines represented by the equations x minus 2y equal to 0 and 3x plus 4y equal to 20 meet at point 4, 2. That is, 4, 2 is their unique or common solution. So if we get that solve the equations graphically, means that they are asking a solution. Means they are asking the common value of x and y. So the common value here for x is 4 and the common value for y here is 2. Consider the following system of equations. 2x plus 3y equal to 9 and 4x plus 6y equal to 18. Look at the graph of the above equations. If you see here, can you interpret what kind of lines they will have? Here a1 upon a2 is 2 upon 4, that is 1 upon 2. b1 upon b2 is 3 upon 6, that's 1 upon 2. c1 upon c2 is minus 9 by minus 18, which is again 1 upon 2. So I think you all can recall that the graph for this will be coinciding lines. Yes, we have the graph as coinciding lines. Means that every solution of the first equation is also a solution of the second equation. This is because of the fact that the equations in the given system are dependent. Another new word that you're coming across, dependent. By dependent equations, we means that one equation can be derived from the other. Here it is evident that the second equation 4x plus 6y is equal to 18 can be derived from the first equation simply by multiplying by 2, and we say that the second equation is dependent on the first equation. Therefore, both the equations will have a common solution set. And how many solutions do you think we can have? Infinite solutions, because every point of the first equation every point of the first line will also lie on the second line. That means every solution of the first equation will also be a solution of the second equation. Graphically, we can see that these equations meet each other at infinitely many points. Thus, the system has infinitely many solutions or infinite solutions. Are you getting it? Make a note of the fact that system of equations is said to be consistent if it has at least one solution. So in the first case, where the lines were intersecting, we had only one solution. So we say that the system is consistent. But here in the second case, we are having infinite solutions. So for sure, that system is consistent. A system of equations is said to be consistent if it has a unique solution or infinitely many solutions. And the graphical representation of a consistent system is either intersecting lines or coincident lines, which I have shown you before. Finally, let us come to the third case, wherein x plus 2y minus 4 equal to 0 is the first equation and 2x plus 4y minus 12 is equal to 0. Just try to guess what kind of representation the equations will have. First case, a1 upon a2 is 1 upon 2. b1 upon b2 is, just check, 2 upon 4. And c1 upon c2 is minus 4 upon 12, that is 1 upon 3. So clearly a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. Case 3, if you can recall, the graph is going to be representing the parallel lines here. Parallel lines means what? That there is no common solution. The lines do not meet each other at any point. So we can say that there is no solution. These equations have no common solution and this represent a system with no solution. No solution means they are not stable. They are not stable means they are not consistent. So we call it they are inconsistent. Thus the system of equations with no solution is said to be inconsistent. Now check out the video to recapitulate whatever we have learnt so far. You can see the video yourself later on. Let us now begin with the exercise questions. These exercise questions of exercise 3.2 are to be done in your classwork registers. The one register that you have made, in the same register you will be doing this work. Just see the question number 1 of your exercise. 10 students of class 10 took part in mathematics quiz. If the number of girls is 4 more than the number of boys, find the number of boys and girls who took part in the quiz. You were supposed to find out the number of boys and girls participating in the quiz. So what we did was, we have taken the number of girls participating be x and the number of boys participating to be y. It is said in the question that the total number of boys and girls is 10. That means x plus y is 10, which is the first equation. Let us try to find the solution set for that. And it also says that the number of girls participating is 4 more than the number of boys. So what we do is, we try to find out the solution set for the second equation also, which is x is equal to 4 plus y. And we try to draw the two lines representing the above equations. These two lines intersect at one common point 7, 3, which gives us the common solution as 7, 3. Thus we can say that x is 7 and y is 3. That is, number of girls participating in the quiz is 7 and the number of boys participating in the quiz is 3. Always your word problem should have an answer also in words. That means your answer should be in the end. From the graph we get that the common solution is 7, 3. Therefore number of girls is 7 and number of boys is 3. The second part, I think you can give it a try. You will do it in the homework. The second question states that you will compare A1 and A2, B1 upon B2 and C1 upon C2 and find out whether lines representing the following pairs of linear equation intersect at a point, are parallel or are coincident. Side by side, you can also think of how many solutions the line will have. So the first part has been done for you. 5x minus 4y plus 8 is equal to 0 and 7x plus 6y minus 9 equal to 0. Let us compare these equations to the general equation and find out the values of A1, B1, C1 and A2, B2, C2. We get what? A1 is 5, A2 is 7, B1 is minus 4, B2 is 6, C1 is 8 and C2 is minus 9. So A1 upon A2 is 5 upon 7, B1 upon B2 is minus 4 upon 6 which is minus 2 upon 3. Since A1 upon A2 is not equal to B1 upon B2, hence the lines representing the given pair of equations has a unique solution and the pair of lines intersect at exactly one point. The rest of the parts of question number 2 are to be done in your notebooks. The second and third part will be homework for you. Let us see the third question. Question number 3. Again, it's a similar kind of question and we have to decide whether the equations are consistent or not consistent. That is, or they are inconsistent. The first part is 3x plus 2y equal to 5 and the second equation for the first part is 2x minus 3y equal to 7. Again, our first step should be to put them in the general form. So we will get 3x plus 2y equal to 7 is equal to 3x plus 2y minus 5 equal to 0 and 2x minus 3y minus 7 equal to 0. So A1 is equal to 3, B1 equal to 2, C1 equal to minus 5 and A2 equal to 2, B2 equal to minus 3, C2 equal to minus 7. A1 upon A2 is what? 3 upon 2. B1 upon B2 is 2 upon minus 3. Clearly A1 upon A2 is not equal to B1 upon B2. So we have a unique solution. So I think it is very clear. You can do the third and the fourth question and the fifth question also in your notebook. It's on the same lines. Let us see the sixth question. Given the linear equation 2x plus 3y minus 8 equal to 0, write another linear equation in two variables such that the geometrical representation of the pair so formed is intersecting lines. Then you have to find out for parallel lines and the coinciding lines. Just see here, for intersecting lines it has been done for you. The next two parts, that is the parallel lines and coincident lines, you will do on your own. See the equation clearly. It is 2x plus 3y minus 8 equal to 0. Can you all recall what is the condition for the lines to be intersecting? Yes, it is A1 upon A2 is not equal to B1 upon B2. We already have one of the equations, so we need to frame another equation in such a way that the given condition is satisfied. For example, if we choose another equation to be 3x plus 2y minus 9 equal to 0. So what do we get A1 upon A2? It is 2 upon 3. B1 upon B2 is 3 upon 2. They are not same. A1 upon A2 is not equal to B1 upon B2 and hence we will get the two lines which will be intersecting. That is, the second equation can be 3x plus 2y minus 9 equal to 0. This way you can find out different equations as per you wish. We can thus have infinitely many such equations which will satisfy the condition that A1 upon A2 is not equal to B1 upon B2. So, you can find out as many equations as you want of your choice. Second and the third part for this question you will be doing on your own. The seventh question. Seventh question is just similar to what you had done earlier. You have to draw the graphs of the two equations and determine the coordinates of the vertices of a triangle formed by these lines and the x-axis and shade the triangular region. So here you see for the first equation x minus y plus 1 equal to 0, we can find out the solution set, the table that we used to draw in class 9th. Similarly, for the second equation, we can again find out the solutions. If we try to plot these on the graph, we will get this kind of a graph. Here, the solution for the equations is the lines are intersecting at x equal to 2 and y equal to 3. Clearly, the solution of these equations is x equal to 2 and y equal to 3. That is the first part, because they had said that we need to find out the solution also. We should ideally find out the solution always. The vertices of the required triangle are given by, just see the points. First point will be 2, 3 where the lines are intersecting. Then on x-axis, the green line you can see is meeting at -1, 0, and the red line is meeting the x-axis at 4, 0. So we have what? We can say that the vertices of the triangle formed will be 2, 3, -1, 0 and 4, 0. Thank you so much. If you feel there's any doubt, you can always send in a query. Thank you so much, children. Go through the PPT as many times as you want. Whatever doubts you have, you may ask me later on. Thank you so much.